Welcome to the Explainer. You know, sometimes in chemistry, it's not just about knowing the answer, but knowing how to write it down. Today, we're going to crack a real GCSE question wide open and show you exactly what a perfect, full-mark answer looks like.
Hydrocarbon questions. Yeah, they can feel a bit daunting, right? But here's the secret. It's not some kind of magic. It's all about method. We're going to show you exactly what's going on in an examiner's head, what they're looking for, so you can lock in those top marks every time.
All right, let's get right into it. We're breaking down question 03 from an actual AQA paper. And we're not just guessing, we've got the official mark scheme. This is our cheat sheet to see the exact phrasing that scores every single point.
Okay, first up, question 3.1. It's a nice, straightforward two-marker. The whole game here is matching molecules to their formulas.
So you see, we've got hexane, which is an alkane, and hexene, an alkene. Your job? Just draw one line from each of them to its correct formula on the list. That's it.
Now, how do you know which is which? Well, here's your secret weapon, the general formulas. For any alkane, like our hexane, the formula is CnH2n plus 2. For alkenes, like hexene, is just CnH2n. And since hex tells us there are 6 carbon atoms, we just pop n equals 6 into those formulas. Easy, right?
And there you have it. You run the numbers and it's perfect. Hexane, with our CnH2n plus 2 rule, links right up to C6H14. And hexene, using the CnH2n rule, goes straight to C6H12. 2 little lines and boom, 2 marks in the bag.
All right, let's keep the momentum going. The next part of the question builds directly on what we just did, that key difference between alkanes and alkenes.
So question 3.2 is all about what you'd actually see happening. It's a classic test with bromine water, and it's basically the go-to method for telling apart saturated hydrocarbons, our alkanes, from the unsaturated ones, the alkenes.
Okay, listen up, because this is super important. The mark scheme is really picky about the wording here. For hexane, the money phrase is remains orange. For hexene, it's becomes colorless. It's not enough to say no change or the color goes away. You got to use that exact phrasing to guarantee the marks.
But why does that happen? What's the science behind it? Well, it all comes down to that double bond in hexene. See, because it's unsaturated, that C equals C double bond can actually break open. It then grabs the bromine atoms in what's called an addition reaction. The bromine gets used up in this reaction and poof, the orange color just vanishes.
Okay, deep breath. Here comes the big one. This is the 6 marker. This is where you get to pull everything together and really show the examiner what you know. It's all about a detailed, structured comparison. So they give us the structures for ethane and ethene, and the task is to compare them in 2 key areas. First, their structure and bonding, and second, their reactions. Now, to snag all 6 of those marks, you absolutely have to talk about both of those things. You can't just focus on one.
Let's tackle structure and bonding first. The number one difference, the thing the mark scheme is screaming for, is this. Ethane has a single carbon-to-carbon bond. That makes it saturated. Ethene, on the other hand, has a double carbon-to-carbon bond, and that makes it unsaturated. That's the core distinction right there.
Okay, now for reactions. And what's cool is this flows perfectly from what we just said about bonding. Because ethene has that double bond, it can do that addition reaction we talked about, and that's why it decolorizes bromine water. Ethane? Nope. It's saturated, it's stable, it won't react with the bromine water. It does other things, like substitution reactions, but that's a different story.
So, to make this crystal clear, we've pulled together every single valid point from the official mark scheme. This is literally the examiner's checklist. You can see the similarities, right? Both are hydrocarbons. Both have 2 carbons. But then you've got those crucial differences. Oh, and here's a little pro tip for you. Even mentioning something simple, like the fact that they both burn, undergo combustion, that's a marking point. Don't forget the easy ones.
Whew. Okay, so we've pulled that whole question apart. Let's step back and summarize the absolute must-know points. This is your key to unlocking top marks. This table pretty much says it all, doesn't it? It recaps the fundamental differences this whole question was designed to test. And you can see how everything, I mean everything, comes back to that one thing. The single C-C bond in alkanes versus the double C-Ce bond in alkenes. That one difference controls whether it's saturated or unsaturated, and that in turn dictates how it's going to react.
The biggest takeaway here isn't just about ethane or hexane. It's about seeing the pattern. Once you really get these core ideas, the structure, the bonding, the reactivity,
You can walk into an exam and confidently tackle a question about any pair of alkanes and alkenes they throw at you.
So I'll leave you with a little challenge. We've just walked through the perfect answer for ethane and ethene. So, what about propane and propene? Or butane and butene? How would you take these exact same principles and apply them? The pattern is all there. You just have to use it.